All right, so today we are finishing up 2.6. So last lesson we introduced these rational functions and we talked about the three types of asymptotes. So today we're going to take that knowledge that we learned in our last lesson and build on it so we can graph these rational functions. So our learning target for today is I can graph a rational function. All right, here's our success criteria typed up for you on page 49 in your note packet. So we have our rational function here. Rational function is the quotient of two functions here. So function on the numerator, function in the denominator. They're both polynomials there. Your first step is to simplify. So you're going to see if you can factor anything and see if there's any common factors and reduce it down if possible. If not, then you would go to step 2 here. So as we go through the success criteria, let's work through problem number 11 here. So for problem number 11, this is not in our success criteria, but in our directions, it says to go ahead and state the domain. So to find the domain of this rational function, the denominator cannot equal 0. So x plus 1 cannot equal 0. So x cannot equal -1. So all the reals except for x is -1. And interval notation looks like this. All right, there's the domain. Now it says to identify all the intercepts. So this is in our success criteria. So step 2, find and plot the Y-intercept. You find the Y-intercept by finding f of 0 or plugging 0 in for x. So -3 times 0 and 0 plus 1. And that would just be 0 over 1, which is 0. So y equals 0 is our Y-intercept. So I'm going to go ahead and plot that. There it is, right here. Okay, now we can go ahead and find our x-intercept. So that's right here, step 3. Find the zeros of the numerator. Those are your x-intercepts. So the zeros of the numerator are your x-intercepts. So our numerator is -3x. I'm going to set that equal to 0 and solve for x. So x equals 0 is our x-intercept, and that's already plotted right here. Now we can find our asymptotes. So our vertical asymptotes, we learned this yesterday, is found by setting the denominator equal to 0 and solving for x. So our denominator is x plus 1. Set it equal to 0. So x equals -1. That is our vertical asymptote. So we're going to go ahead and mark that on our graph here. All right. Now we're going to look for our horizontal asymptote. So that's step 5 up here. Find and sketch the horizontal asymptote. So you're going to have to go back to your notes from yesterday. And in this case, you're looking at your degrees. So the degree of the numerator is 1. And the degree of the denominator is also 1. 1 equals 1. So when the degrees are equal, numerator degree equals denominator degree, this is when you take the leading coefficients. So leading coefficient of the numerator is -3. Leading coefficient of the denominator is 1. So y equals -3 would be your horizontal asymptote. So we're going to go ahead and mark that. Okay. Then we're going to check for a slant. Slant means it has to be exactly, the numerator has to be exactly 1 more than the denominator. These are equal, so there's no slant. No slant for this one. And then finally, we're going to go ahead and plot additional points. So now we're right here at step 6. Says to plot additional points, you're going to find 1 point between and 1 point beyond all the x-intercepts and vertical asymptotes. So here's your vertical asymptote here. Here's your x-intercept. So we're going to pick some points. It doesn't really matter what you pick. Just be reasonable with your numbers because you do have to plug them in and graph them there. So I'm going to say, I'm going to pick 1, and then I'm going to pick between here, that would be between 0 and -1 would be -1/2. And then I'll plug in -2 because that's beyond this vertical asymptote. So I'm going to take these numbers and plug them into our original equation here. So in other words, if I'm plugging in 1, I'm going to do -3 times 1 is -3 over 1 plus 1 is 2. So -1.5. So I'm going to plot that point, 1, -1.5. Now let's try -1/2. So plug in -1/2. So -3 times -1/2 would be 1.5. And then -1/2 plus 1 is 1/2. Divide that and you get 3. So -1/2 and then +1, 2, 3. Okay, so now we can kind of see what this is going to look like. Remember those asymptotes, your graph, your function gets closer and closer to these asymptotes but never touches it. So that's that part of the graph. Let's try -2. So plug in -2 into your function and you would get -6. -2, -6, and that would be the starting point of this part of our graph here. Now, these didn't quite get me to my whole graph, so I'm going to go ahead and pick some more points to kind of see what's happening here. So I'm going to try -4, -3. Let's try those. So if I plug in -4, I get 12 over -3, which is -4. So -4, -4. When I plug in -3, I get about -1.8. Oh, no, that's not right. -4.5. Sorry, I was looking at something else there. All right, so -3, and then down -4.5. Okay, so now I have a little better idea of what this graph is going to look like. There we go. Okay, so that's it. That's how you graph these. So keep that success criteria handy. And we're going to go ahead and do 2 more examples. So go ahead, pause the video, try these next 2 on your own, and then we'll check them. All right, let's see how you did. So remember, always try to simplify first. That's step one of your success criteria. So this bottom, this denominator can be factored. And after you factor that, you see the common factor of x plus 1 cancels out. So this simplifies down to 1 over x minus 4. And we're going to work off of that. So you would first find your domain. And you're using this simplified expression, rational function there. So denominator cannot equal 0, so x cannot be 4. So all the reals except for 4, or if you wanted interval notation, you could write it in interval notation like that. Okay, now we're going to find the y-intercept. So we're going to plug in 0 for x and simplify, so that ends up being 1 over negative 4. Or simply negative 1/4. About right here. Plot that. Check for an x-intercept. Oh, there's no x in our numerator. So for finding x-intercept, you set the numerator equal to 0. Well, 1 does not equal 0. So there's no x-intercept. Okay, now we're ready to check for asymptotes. We'll start with the vertical asymptote first. Take the denominator equal to 0. So x equals 4 is your vertical asymptote, and go ahead and mark that. And then to find your horizontal asymptote, you're looking at the degrees. So degree is 0. Degree is 1. 0 is less than 1. So you look at your chart, your rules there. When the degree of the numerator is less than the degree of the denominator, that's y equals 0. So there's your horizontal asymptote there. There's no slant. And then we're going to make our chart. Just plug in a bunch of numbers here. Kind of working around your vertical asymptotes, any x-intercepts, which we don't have. Plug those in. Just fill these in for you to save time. So you're taking the x term, the x number, x value, plugging it in here. So for example, this would be 1 plus 1 is 2 over, then you would do 1 squared minus 3 times 1 minus 4, reduce it down, simplify it to negative 1/3. Then go ahead and plot those. So 1, negative 1/3, 2, negative 1/2, 3, negative 1, 5, positive 1, 6, 1/2, 7, 1/3, and you can kind of see what it's going to do there. Whoops. So it gets closer and closer to the asymptote, but never touches it. All right. Let's check your 13 here. Try to factor it, see if we can simplify it down at all. This one, there's no common factor, so this can't be simplified. Check for the domain. Denominator cannot be 0, so x cannot be negative 1. So all the reals but negative 1. Okay. And then we're going to find our y-intercept by plugging in 0 for x, So you end up with -3/1 or -3. Plot that. X-intercept, set the numerator equal to 0, and it's already factored up here, so I just copied that down there. Okay, so 1, -3, plot those. All right, now we're ready for our asymptotes. So we'll find the vertical one first by setting the denominator equal to 0. Mark that. Horizontal, looking at the degrees, so 2 is greater than 1, which means we're going to have no horizontal. And then finally, we do have a slant for this one because the degree of the numerator is 1 more than the degree of the denominator. So remember to find slant, we learned this yesterday, or in our previous lesson, you have to divide this. So divide the numerator by the denominator. This we can use synthetic division because it falls into that x minus k here. So this would be -1 that we're dividing by, and then fill in your numbers here for your synthetic division. Remember to ignore the remainder. So this is just x plus 1. Y equals x plus 1 is your slant. Okay, so to mark that, you're going to have to graph this linear equation here. So you start at the y-intercept of 1, and then your slope is 1/1, so up 1/1. And there you have that slant asymptote. All right, now we're ready to make our chart. We're filling in some numbers around the x-intercepts and the vertical asymptotes, so around these 3 points there. So plug in 3 into your equation, simplify it, and you get 3. So 3, 3. And you can see what this is going to look like here. Okay, -5, 3. -5, -3. And then -2, 3. And then you can see what this one's gonna look like. All right. So that concludes our lesson on graphing rational functions. Now you're ready to try it on your own.